Good afternoon. Uh, this is Ahatube. Now, our today's topic is mathematical induction. Induction, and mathematical induction is used to prove different propositions involving positive integers using three simple steps. Okay, we use three simple steps or three steps to prove a mathematical induction. Now, the three steps are the following. Step one, prove that tk, usually called t1, holds true. tk or t1 holds true. The second step is assume that tk for k is equal to n. K is equal to n is also true. This is assumption. The third step is show that tk is true for k is equal to n plus 1. N plus 1. So these are the three steps to prove mathematical induction. The first step, proving the first member holds true. The second one, assume that, this is an assumption, assume that the induction is working for tk wherein k is equal to 1. And the third step is claiming it's true for k is equal to n plus 1. Here we have an example. This is a mathematical induction. 1 plus 3 plus 5 plus 2n minus 1 is equal to n squared. N squared for n is equal to, for n is equal to, n is equal to, for n is equal to, n is greater than or equal to 1. Now, in this mathematical induction, now the first step is proving it holds true for tk, usually t1, is true. And the second step is assuming k is equal to n. The third step is showing it's true for k is equal to n plus 1. N plus 1. Let's see this on the other side. Good. Here we have the example. So step one. Now prove that it holds true for n is equal to 1. Or let's say n is equal to 1, meaning k is equal to 1. tk or k is equal to 1. So the first element in the series is 1. The others are not here because this is for the first element. So 1 is equal to. Here we have on the other side, m is equal to 1 squared. This implies 1 is equal to 1 is true. So this is true. True. Now the second step is step 2. Assume that tk is true for k is equal to n, or n is equal to k. N is equal to k. That is 1 plus 3 plus 5 plus in the bracket 2n minus 1 is equal to k minus 1 is equal to k squared. This is an assumption. 1. Assume that tk is true for n is equal to k. So we are supposed to replace k instead of n. Then 1 plus 3 plus 5 plus 2k minus 1. 2k minus 1 is equal to k squared. 2k minus 1 is equal to k squared. Now here we have the third step. Step 3. Now here we are supposed to show. We want to show that the induction, the series is true. It's true. Show that it's true for k n is equal to k plus 1. K plus 1. Now, this is to mean, okay, this is to mean the series, okay, 1 plus 3 plus 5 plus, this is 2n minus 1, okay, this is up to n, then plus 2 into 2k plus 1, plus 2 into k plus 1, minus 1, okay, this is the k plus 1 term, this is equal to k plus 1 square, k plus 1 square, okay, this is the k's term, okay, k. Now this is the k plus 1's term, okay. Now let's see. Now this is 1 plus 3 plus 5 plus 2k minus 1, okay, plus this is 2 times k is 2k, 2 times 2 is 2, minus 1 is equal to k plus 1 square is k plus 1 times k plus 1, k plus 1. Now again, this is 1 plus 3 plus 5 plus 2k minus 1 in the bracket plus 2k plus 1, this is 2 minus 1 is 1, 2k plus 1, this is equal to k square plus 2k plus 1. K times k is k square, k, then 2k plus 1. Good. But from step 2, from our assumption, we know that 1 plus 3 plus 5 plus 2k minus 1 is k square. K square. So that this assumption holds true. Okay, we assume this is k square. Now this k square is here. This k square is here. This is the k square. So instead of this, we can write k square plus, here we have 2k plus 1. This is equal to k square plus 2k plus 1. Okay, plus 1. Now the series holds true. Okay. Now the left side of our equation is equal to the right side. Therefore, 1 plus 3 plus, this is also true, we show that this is true, plus 5 plus, okay, plus 2n minus 1 is equal to n squared holds true for all n greater than or equal to 1. Okay, we prove it. Actually, this is an example. Okay, this holds true. This holds true for all n is equal to 1. This is the last step, and we prove it. It holds true for n is equal to k plus 1. N is equal to k plus 1. So, in doing mathematical induction, in dealing with mathematical induction, the best thing you have to do is keeping the 3 steps in mind so that you manipulate, okay? You prove for all n in the domain. The steps, just to remind, prove that tk, usually t1 holds true. Second step, we assume, this is assumption, assume that tk for k is equal to n is true. And the third step is show that tk is true for all for k is equal to n plus 1. If the induction, if you are able to prove the first and the third step, you can generalize the induction is working true. Okay, the induction holds true for all n in the domain. Let's see another example. Well, here we have an example. Still, this is solved on your textbook. Example 2. Show that 1 plus 3 plus n is equal to n into n plus 1 over 2. Now n is an element of integer, n is equal to or greater than or equal to 1. So we are supposed to show that this holds true for all n greater than or equal to 1. Good. Now remember our first step. Our first step is to show that this holds true for n is equal to 1. Okay, because we said that n is an element of, or n is greater than or equal to 1. So step 1, 1. Okay, for n is equal to 1, the first element is this one. So 1 is equal to n is equal to 1, then 1 into 1 plus 1 over 2. Now 1 plus 1 is 2, 2 times 1 is 1, so this is 2 over 2. This is equal to 1. So 1 is equal to 1. Then from this we can say that for n is equal to 1, this is true. Okay? For n is equal to 1, 1 plus 2 plus 3 is equal to n over n times n plus 1 over 2 holds true. From this, for n is equal to 1, now 1 plus 2 plus 3 plus, okay, plus n is equal to n into n plus 1 over 2 is true. This holds true. Okay, this holds true. This is the first step. Okay, this is the first step. Now the second step is assuming that this is working for k is equal to n. K is equal to n in the domain. Step 2. Assume, this is assumption, assume that it's true. It's true. This is true. It's true for n is equal to, or k is equal to n. N is equal to k. N is equal to k. That means tk is true. Tk is true. This means now 2 plus 3 plus n, meaning now k, okay, plus k is equal to k into k plus 1 over 2 is true. This is our assumption. 1 plus 2 plus 3 plus k is equal to k times k plus 1 over 2. This holds true. This is our assumption. This assumption helps for the third step. Okay, this assumption helps for the third step. So our third step and the critical step is, okay, step 3. This is a critical step. We want to show that it's true. It holds true. It holds true for n is equal to k plus 1. This is a critical step, supported by the second step. Okay, this holds true for n is equal to k plus 1. K plus 1. So how can we write this series for n is equal to k plus 1 is the vital or the important thing in mind. Then here the series is 1 plus 2 plus 3 plus k. This is the nth term. Okay, plus again k plus 1. Okay, k plus 1, because n ends at k plus 1 is equal to k plus 1, because n is k plus 1 times, now if n is k plus 1, this is k plus 1, k plus 1, k plus 1 plus 1 is k plus 2, okay, or k plus 1, again plus 1 over 2. Now here 1 plus 3, 1 plus 2 plus 3 plus k plus k plus 1 is equal to k plus 1 times k plus 2 over 2 over 2. Okay? Again, this is to mean 1 plus 2 plus 3 plus k, okay, plus k plus 1 is equal to, this is k squared plus 3k plus 2 over 2 over 2. Okay, over 2. Now, at this stage, it's better to refer back the step 2, okay? The support of the step 2. Now, at step 2, okay, on step 2, we have this. Okay, we have this. Okay, 1 plus 2 plus 3 plus k is equal to k times k plus 1 over 2. Meaning, this one is, okay, this part of our series in the third step is simply equivalent to k into k plus 1 over 2 only this part. Okay, then here we have k plus 1. This is equal to k squared plus 3k plus 2 over 2. If the two sides of the equation, if the two sides are equal, then it's true that our induction is proved. Let's see what's coming. Okay, now this is k squared plus k over 2, okay, plus, now taking 2 as a common factor, over 2 plus k plus 1 is equal to k squared plus 3k plus 2 over 2. Now taking 2 as a common factor, okay, 2 as a common factor. Now this is equal to k squared plus k plus 2 times k plus 1, okay, is equal to k squared plus 3k plus 2 over 2. Now here we have 2 times k is 2k. 2k plus k is, now this is k squared, okay. Let me move this down. Okay, this is k squared. This is over 2. Okay. Now this is k squared plus 3k, because k plus 2 times k is, then 2 times 2 is 2, okay, over 2 is equal to k squared plus 3k plus 2 over 2. Now the left side of our equation is the same as with the right side. Therefore, now from this point, okay, now this is true, okay, this is true. So this is true, okay, meaning this series, okay, meaning this series, okay, this series 1 plus 2 plus, okay, holds true for n is equal to k plus 1. This series, okay, this series, the above series, okay, hold true for n is equal to k plus 1. Therefore, what is our final assumption? What is our final conclusion? Therefore, okay, 1 plus 2 plus 3 plus n is equal to n into n plus 1 over 2 for all, okay, for all n greater than or equal to, okay, for all n greater than or equal to 1, greater than or equal to 1, for all n greater than or equal to 1. So this is how we prove mathematical induction. So this is how we prove mathematical induction. Simply to revise the steps, the first step is prove that it's true for n is equal to, for k is equal to 1 for the first term. The second step is assume that it's true for n is equal to k. The third is claiming or showing it's true for n is equal to k plus 1. N is equal to k plus 1. And do not forget to like and share, okay? Do not forget to like and share. And this is a heart tube, okay? This is a heart tube, okay? This is a heart tube, okay? A heart tube. Your partner in academics, in maths, physics, and engineering, and engineering, okay? So, like, and share, and subscribe. Subscribing help us to stay with you for long. Thank you for watching.